Hello everyone, Storm11 here. Today we'll be having an update on the storm system that's going to bring in a multi-day severe weather event beginning Tuesday night across parts of the Central Sever Plains. There's still some uncertainty with Tuesday's night setup, but there's better confidence as we get into Wednesday for parts of Dixie Alley, even as possibly as far north, into parts of the Ohio Valley as well. And that could also lead into Thursday as well across parts of the Mid-Atlantic as well. Before we get started with this video, if you guys would like weather related content, you can subscribe to my channel. We do this stuff here all the time on this channel. Plus, we will have a couple more updates on the setup here as well. So definitely stay tuned for more updates as well. So let's get started with the watch and warning advisory display. And generally, mostly quiet in the eastern U.S. We did have snow squalls and snow showers in the northeast earlier today. That's caused major problems out there. We've got, we still got freeze warnings for parts of eastern North Carolina as well. It's going to be another cold night for those areas. Even just generally parts of the eastern U.S., it's been very cold over the last couple of days. But as you get further to the west, things do pick up on activity. You got a mix of winter weather and wind advisories across parts of the southwest. Part of that is a storm system that's going to come on shore to California, and that's going to be the same storm system that's going to bring these big problems when it comes to severe weather across parts of the central and eastern U.S. as well. And unfortunately, fire weather issues is still continuing across parts of the several plains as well, especially in the parts of western Texas, as when unfortunately that's going to continue over the next couple of days. The severe weather outlook for tonight, maybe some thunder across parts of the west. And then here's tomorrow. We got a slight risk for severe weather from central Texas all the way up into far southeastern Nebraska and far southwestern Iowa as well. When it comes to the tornado risk, the greatest risk for tornadoes will likely stay a little bit further south, more in the parts of Texas and Oklahoma. Damaged winds could be there, but there could also be some hail with some of those storms as well. Then again, there's still a lot of uncertainty, especially when you get further north as well, because this could potentially be capped for most of the night as well. And by the way, this is looking to be a nocturnal event as well, which that means that severe weather could go on through the overnight hours as well. And then on day 3, which is Wednesday, got an enhanced risk for severe weather for parts of central and eastern Louisiana, for most of Mississippi into the west parts of the western half of Alabama. And when we do have that enhanced risk, is where we also have the possibility for some significant severe weather, which is in the hatched area as well. That's where we could possibly see significant damage to winds, and maybe for the possibility for strong tornadoes as well for Wednesday. And then on day 4, which is Thursday, slight risk from parts of southeastern Pennsylvania and southern New Jersey, all the way down to parts of central North Carolina as well. So let's get started with the NAM model. You can see here with that storm system coming on shore, that's going to bring us some winter weather and a decent amount of rain too, which is good news. The desert Southwest could really use quite a bit of rain as well, and also just generally the western U.S. can use a lot of rain. And really, as you get into Tuesday, you get a strong low pressure system that comes out of Rockies. At this point here, around peak time heating, or close to peak time heating, I should say, for Tuesday, really by later in the day on Tuesday, you got a 989 millibar low in northwestern Kansas. And that's going to continue to move off to the northeast. And you notice here, especially when you get closer to the overnight hours, not much of anything's developed. Main reason why? It's capped. Nothing can develop until you get deeper to the overnight hours. Then you can see here, as we get deeper into the Tuesday night, thunderstorms do begin to develop in the parts of Oklahoma and Texas, but not a whole lot's happening further north as well. So there's still uncertainty, especially when you get further north, if the cap is going to stick there for most of the night. So that's really the uncertainty we got with this here. But if the cap does break early, we could see the possibility for all hazards as well for most of the region anyway. The greatest tornado risk, then again, will be more in the parts of Oklahoma and Texas. And as you continue to move further off to the east, you notice here by Wednesday morning, You got a squall line of storms that stretches from parts of southern Missouri all the way down to parts of eastern Texas. And this will be continuing to move off to the east as well. We're likely going to see a squall line for Wednesday setup, but there is greater potential for a more discrete type of setup for areas a little further south, especially where you have the significant area. But for areas further north, it's looking to be more of a linear type of event as well. And then you should get into Thursday. Later in the day on Thursday here, you got a strong low over parts of southern Canada. And along that cold front where we may see some strong storms as well, there's going to be a decent amount of instability to work with. And really, the showers is the ones that are going to produce the possibility for damage winds, which looks to be the primary threat at this point. But may have to watch parts of Pennsylvania. There may be better wind shear to work with that could increase that tornado potential as well. Okay, let's get a little bit more detail into Tuesday night. So you can see here, by early in the day on Tuesday here, not much is happening, but it seems like the Hermon likes to break the cap a little bit early. That's what the some of them all suggest. So that's a little bit interesting. And you can see what happens when that cap does break. Thunderstorms develop, and some of those could be strong as well. And when they first blow up, there's going to be a decent amount of instability, and that could lead to the potential for some large hail with some of those storms as well. You can see here it's supposedly a squall line too, indicated by the HER model as well. And you also do notice that there are some Boeing segments along this cluster of thunderstorms as well. And it's also kind of broken as well, more of a broken line than more of an organized line. And anytime we get a broken line of storms, that does increase that QLCS tornado threat as well, which is something I'm going to need to keep an eye on as well. If you check out surface space cape, one of the ways to look at if it's capped or not is sign in. And anytime when you get sign in, that's where you could possibly see a cap in there. And that's the gray shade out here. That's indication that's cap. What you can see here, right by Tuesday evening, you can see you got strong sign-in values really pretty much across the entire warm sector. It does get weaker in the parts of west central Texas, but generally it's capped through the entire warm sector. And you can see here as we get deeper into the overnight hours, you notice here it does begin to weaken a little bit as well when those storms do begin to fire up. Plus, there are some pretty decent instability values out there as well, up to 1,000 joules per kilogram out there. When it comes to superset composite there, you got some pretty favorable values there out there. There's going to be a decent amount of wind shear to work with this setup as well, along with instability. And you can see here how those numbers really begin to ramp up as you get into Wednesday here, especially across parts of Louisiana as well. That's where we could possibly see more discrete mode out there as well. And you can check out the updraft Felicity softs, which indicates the possibility for rotating thunderstorms. There's a lot out there, but the majority of them is on the weaker side. But there are a couple areas out there, especially on the southern end of that squall line or that cluster thunderstorms. That's where they'll have better inflow to work with, so those may have better potential to produce tornadoes out there as well. So that's also something to keep an eye on, as well as that southern tail end of the squall line may have better potential to produce tornadoes as well. Let's check out the NAM model here when it comes to Tuesday. You can see here at 500 millibar winds, it's mostly a possibly tilt trough here. So it's not too big of a tilt trough, but even with a possibly tilt trough, it can still create severe weather out there. It does become a little bit more neutrally tilted as you get deeper to the overnight hours as well. There's also a decent amount of divergence out there as well. It's not a very strong divergence out there. So there's the lift is not very strong out there, but it'll be enough for thunderstorms to develop. But when you get to Wednesday, you notice here around peak time heating on Wednesday, our trough does begin to become more negatively tilted out there as well. But also at the same time, though, there's the winds, especially the northern end, is going to be pretty strong as well, which might be able to help prevent that messy mode further north. But there's also other factors that's going to prevent that messy mode up north as well. And that's also dew points are going to be on the lower end as well, upper 40s to low 50s. That's also going to help prevent that very messy type of storm mode further up north as well. So really, overall, the squall line of storms here, or just cluster thunderstorms, there won't be a whole lot stopping it out ahead of us as well. But there's still a lot of uncertainty when it comes to instability as well. And that's really the main uncertainty we got from the northern mode is how much instability can we see here? Because the more instability we get, the more severe these storms could be and potentially significant as well if we do see a lot of instability for the squall line as well. So it's going to be interesting to watch and see. But where we do have a little bit more discrete mode, there's better divergence, a little bit more lift out there as well, which could lead to more discrete storms out there as well. You also, of course, got better moisture. And also, lap rates won't be too bad either, which also may help bring in a little bit more discrete mode. But really, generally, areas for up north here, it's mostly going to be a linear event. But if you live in the parts of southern Mississippi, Louisiana, even the parts of southwestern Alabama, got to keep an eye on that potential for strong tornadoes as well. It's really something you have to keep an eye on as well because those storms are likely to be more discrete in those areas further south as well. If you check out the low jet, kind of going back to Tuesday night, you can see here it's a decent low jet out there. But look when you get into Wednesday. When you get into those purple shades, that's a pretty strong low jet. You can see here it's generally 80 to almost 90 knots. That's a very strong low of a jet, especially for this time of year. I mean, well, it's pretty darn strong for any time of year. Regardless, it's a very strong low of a jet. So the wind shear values are going to be pretty high. They're going to be way up there when it comes to wind shear values out there. If we check out some other ingredients here, let's check out surface-based CAPE. You can see here, you got pretty good instability values, especially a little bit further to the south here. If we kind of back this up a little bit, the main squall line here may get, it's mostly a prefrontal convection boundary. The cold front's actually still a little bit further back off to the west, and there's a possibility we could see more redevelopment along that cold front as well, which you can see here. Here's our prefrontal convection storms right here, and there's just a little bit of instability out ahead of it. We also notice here there's another slug of instability just behind that, and that's actually going to be your main cold front. So there might be some areas that may possibly get 2 rounds of strong to severe storms, and both of those are more likely going to be linear as well. So certainly pretty interesting. You will notice here, which the NAM can be a little bit underdone with instability values, but still even being a little bit underdone, these are some pretty good instability values out there. Showing 1,000 to 2,000 joules per kilogram over most of the state of Mississippi, which is very interesting. If you check out surface composite values, you can see here they are pretty elevated out there as well. And then again, this is more into Wednesday evening. And you got numbers as high as a 10 or 11, which is pretty darn high. But let's kind of go along the Mississippi and Alabama state line. And you can kind of see here, the lap rates are not very strong out there. And also, the prefrontal convection boundary out there, that's going to have very strong wind shear. But behind it, not as much wind shear going on just behind this prefrontal convection boundary. But there will still be enough for severe weather. That should be noted as well. And then again, lap rates out there, not the best, but they are okay. But the elevated mix layer here, you can see here it's pretty strong out there, which can lead to a more discrete mode out there as well, which can lead to the potential for supercells out there as well. Because if we go back to reflectivity, and really the NAM's not the best job when it comes to reflectivity, but you can see what I'm kind of talking about here. Your prefrontal convection here is actually out ahead of those favorable CAPE values. At the same time, that's also where your most favorable wind shear values are. It's going to be kind of along and ahead of that prefrontal convection line. The cold front is still back here, and that is where we have the most favorable instability values. But at the same time, the wind shear values won't be as high back there as well. And you can see here, it does show some activity across parts of northern Mississippi, western Tennessee as well. But then again, the NAM does not do the best job when it comes to reflectivity, so this may not turn out this way. It'll be interesting to see whether the hard model comes to range, because the hard model does have a little bit of a better handle when it comes to reflectivity as well. And I also should note here that these models here are likely to be underdone when it comes to temperatures. Like if we check out the temperatures here to right around peak time heating, let's actually zoom in here so we can kind of get a better view here. Let's go to the Midwest. Because let me show you guys something here. And these models do have a tendency to do this. And you can see here temperatures generally, 70 to 75 degrees. That's pretty warm. But they're likely to be warmer than that because the winds out of south are going to be pretty strong, which we'll check out the wind gust forecast for the NAM in a little bit. But they are going to be pretty strong. If we get a lot of sunshine out, the numbers here from the NAM model and really generally most of the weather models are going to be overdone. And what happens when you get warmer temperatures? It can lead to a little bit more of an unstable atmosphere as well. The atmosphere becomes a little bit more unstable, and that can lead to more favorable environment for our squall line of storms, or a preferential convection line of storms that roll quickly to the east as well, and that can make them a little bit more severe as well. And also at the same time here, this can also increase your low lap rates, which can also help bring in some of those stronger wind gusts as well at the same time, even outside of storms as well. So that's something that I should know real quick, because some of these models here, they're likely going to be underdone with temperatures, and whenever you get underdone temperatures, sometimes that can underestimate the instability values. So that's something to really keep in mind there as well. So it'll be interesting to see how some of the models turn out here. See if they trend to be more accurate with higher temperatures. If we check out the HighRes NAM here, now I don't typically show the HighRes NAM that much because it doesn't really do a good job. But for a more linear type of event setup here, I think it may not be too bad of an idea to link it to the reflectivity. And then again, the main reason why that don't show the HighRes NAM that often, because it's pretty crap when it comes to reflectivity. When it comes to more discrete type of setups out there, it likes to cluster everything up out there. So that's something that should note as well, which, that's not very accurate. But with a setup like this, it's mostly going to be a linear event, so it may have a little better handle with it. And you can see here, really by the early morning hours on Wednesday, here comes your squall line right here, which it does extend as far north as southeastern Oklahoma, and it goes down as far south as parts of east central Texas as well. And look how this kind of progresses here. And look at this moment here around peak time heating. Our squall line stretches from possibly as far north as central Illinois down to possibly as far south as central Louisiana. That's a pretty long squall line. And our cold front is still back here. You can see there's still more storms forming behind this front, or behind this prefrontal convection boundary as well. Some of these areas further back off to the west may have enough time for the environment to recover. The wind shear values won't be as strong back there, then again, but the instability values are likely to be much higher than what's going to be out ahead of this main squall line as well. And as you expect here, if this were to be correct with all this convection air out ahead of the main squall line here, these storms would begin to weaken. But look as you get further to the south here, you can see right here, that's a pretty intense band of storms, if I got to be honest with you. And there's not much convection out ahead of it as well. So if the HighRes NAM were to be correct, that could lean into a pretty significant damage and wind event. The amount of wind energy, then again, we have is pretty high, and the more instability we get could lead to more severe storms as well, and they could be possibly significant. That can also lead to possibly for significant wind gusts, which is 75 miles per hour or higher. And you can see here as we get towards the end of the run, you can see how that squall line does continue. But also at the same time, though, if the HighRes NAM were to be correct, this could possibly be a derecho type event. The possibility could be there this may turn out to be a derecho. But then again, we'll have to wait and see how models kind of trend with this setup here over the next couple of days as well. And here's HighRes NAM. We'll put more detail here. This is 12 o'clock on Wednesday. Very strong low of a jet out here in place. Here's 5 o'clock here. Here's your main squall line here. You notice here with that low of a jet just out ahead of that squall line. Very strong winds. Winds could be anywhere from 90 to 95 mile per hour winds out ahead of this main squall line, so from the south. So it will be quite strong. And then again, and then you look into the surface here when it comes to sustained winds, you can see, yeah, pretty strong sustained winds out there as well. If you look into Cape here from the HighRes NAM, you can see are out ahead of that squall line. Not a whole lot, but if you get further south here, there's better instability values as you get further south here. But you also notice behind this frontier, or this pre-frontal convection boundary, there's also more instability back there as well. And you see as we get deeper to Wednesday, if this is going to load here, instability values really pretty much back off further north here. There's still a little bit left, but not much of anything. But as you get further south here, there's still a decent amount of instability left. And the severe weather further to south will likely continue deeper to the overnight hours than areas further north as well. So certainly pretty interesting setup here as well. And then again, here's the HER model here. This is kind of an example here of what could happen here. This is the max end run. I cannot go further out, but this is 18Z on Wednesday, so this is basically late afternoon. And you can see here with your main squall line here, the HER model has actually got to stretch it up farther north, possibly as far north as north central Illinois. That's pretty crazy here. But you also notice here, it's not it's more of a broken line, and that's kind of concerning here when you have a broken line because that increases your tornado potential. Anytime we have a broken line like this, for example, here, that could always indicate that you could have stronger inflow as well, which can cause things to spin, and some of those spin ups could lead to QLCS tornadoes out there as well. You also notice at the same time here, even though you got broken line, you do have these little bowling segments out there as well along the squall line, and that can lead to the potential for some damaging straight line winds as well. So it's definitely something you got to keep an eye on as well with this big squall line here, because this may have potential to be a widespread damaging wind type event. It all depends on how much visibility could see out ahead of this, because that can really determine how significant this setup could turn out to be. One of the meteorologists out in the Paducah area posted this on Twitter. Here's his name right here, Noah Burgeon. I apologize if I've pronounced your last name, mispronounced your last name wrong. But anyway, he showed this, and this is very interesting. So this is upper level winds. So this picture right here, this is 200 millibars, 500 millibars, 700, and then 850. What this tells you here is really compared to average, really. And you can see here at 500 millibars, the winds out there, they're going to be stronger than average. But pay more attention to 700 and 850 millibars. You notice here these red colors begin to show up here. That's an indication that these winds here will be very strong here compared to climatological records as well. Especially when you get those bright reds. Bright reds indicate the possibility for record wind speeds out there compared to climatological records. If I were to verify, you could possibly see record breaking or records for some of the strongest wind gusts around this time of year. So really, this really gets to tell you how much wind energy these storms really have out there and how much wind shear we have as well. So it's certainly going to be very interesting to watch and see. Not only will we be experiencing severe storms, but even outside of storms, we could also see strong wind gusts as well. And this can happen throughout the entire warm sector as well. This is what happens when you get a tight pressure gradient and also a very strong low, and at the same time, a very powerful low of a jet. This is the NAM model when it comes to wind gusts And you can see here, now these numbers are likely going to be overdone. I've seen this happen multiple times in the past, where these numbers here do get overdone. So take it off maybe about 5 to 10 miles an hour. That'd be a more accurate reading. And even taking it off by a little bit, I mean, these are still strong winds. I mean, look at this. This is bad peak time heating on Wednesday. Western Kentucky, Western Tennessee, Northern Mississippi. You got this NAM, the NAM all spinning out wind gusts of 60 to 65 miles per hour. And this is outside of the storms. That's pretty darn impressive out there. And if I were to be correct, that could do damage by itself here. That could cause a lot of issues. That could also lead to the possibility for isolated power outages as well. So wind gusts this strong here, even 40 to 50 plus mile per hour winds can also still cause issues out there as well. So even if you don't see much way severe weather up here in north, you're certainly going to see strong southerly winds out there as well. So if you're going to be driving, especially in high profile vehicle, definitely use caution with these wind gusts. I mean, look at this. Getting towards Wednesday night. You got wind gusts. I mean, that's a 67 mile per hour wind gust spinning out for the NAM over Richmond, Kentucky. I mean, that's just insane. And this really tells you that the winds are likely going to be pretty strong with this disappear as well, even outside of the storms as well. So it's definitely something we really need to keep an eye on as well. And also, if you got any loose objects out there outside, definitely strap them down or take them in because there's a good chance that they could be blown around or possibly get blown away as well. I want to kind of backtrack a little bit. Let's get slightly in a little bit more detail to Thursday's setup here. And then again, like I said earlier in the video, it's looking to be more of a damage wind event than anything else. The upper level winds will be strong here, but there's just not a whole lot of wind shear to work with. Maybe a little bit more wind shear over parts of Pennsylvania, maybe a little bit more discrete mode up there, which could increase the probability for tornadoes. But really, overall, this is looking to be a widespread, well, not widespread, but more of a damage wind type of event. If you look at the 850 millibars at 2 o'clock here, you do have strong 850 millibar winds. 500 millibar winds. They're pretty much at the same direction here. Even at the surface here, they are a little bit more to the south here, but really, generally overall, there's not a whole lot of wind directional of height going on here, and that's going to kind of decrease your tornado probabilities as well. There will be a decent amount of instability to work with as well, which could help increase the severe weather threat. But overall here, I think this is going to be more of a windbag type of event on Thursday for parts of the Atlantic. And that could get as far south as parts of the Carolinas as well. But anyways, guys, that's all for you guys today. Hope you guys enjoyed this video. Guys, like this video, hit the like button. If you do like my channel, hit the subscribe button, hit the bell notification so you never miss an upload. If you guys have questions about this, put a comment section down below. I answer you guys questions. I'll see you guys in the next video. Goodbye and have a good day.